Hi class, in lesson 2.3 we will be investigating factors and greatest common factors. Learning target for today, we will determine the greatest common factor of two or more numbers. Key terms to look for in this lesson: common factor, greatest common factor, acronym GCF, and relatively prime numbers. Let's take a look at the lesson introduction to get us ready for 2.3. It says that state fairs, county fairs, and harvest days have been taking place for over a century. It is believed that the first state fair took place in 1841. State fairs are not only fun, but they are about big competition too. Farmers display their prized pigs, cows, chickens, well, almost any farm animal you can think of, in hopes of attaining the blue ribbon. And the competition isn't limited to just animals. Competition for largest vegetables, bake-offs, and feats of strength have also been part of state fairs. We, of course, have our famous Wisconsin State Fair. Just talk quickly with your group members if you've ever been there and some of the favorite things about the state fair that you like. On page 70 in problem 1, we are looking at Harvest Day. Number 1 says, Pat is creating thank you fruit baskets for the adults who will volunteer at Saturday's Harvest Day event. She wants to make sure each basket contains an equal quantity of each type of fruit. She has 24 bananas, 12 apples, and 18 oranges. To get started today, I would like you to answer letters A, B, and C with your group members. If we take a look at letter A, Pat is going to be able to assemble 1, 2, 3, or 6 baskets of fruit. For letter B, the greatest number then of fruit baskets that Pat can make is going to be 6. And for letter C, if we know that 6 is going to be the greatest number of fruit baskets that Pat can make, then there are going to be 4 bananas, 2 apples, and 3 oranges in each. We know that Pat needs to make sure that each basket has the same amount of each type of fruit, so she can calculate the greatest number of baskets possible, which we know is 6, and each of them having the same amount of each type of fruit, and she can divide each quantity of fruit by the number of baskets. Let's turn to page 71 and take a look at number 2. It says that Michelle is organizing student teams for the scavenger hunt at the Harvest Day event. She wants to make sure that each team has an equal number of boys and an equal number of girls. There are 42 boys and 12 girls who signed up to participate in the scavenger hunt. Again, with your group members, I would like you to answer letter A, B, and C. Make sure for letter C that you are explaining your reasoning. For letter A, Michelle is going to be able to organize 1, 2, 3, or 6 teams for the scavenger hunt. For letter B, the greatest number of teams that she can form is going to be 6. For letter C then, if there are 6 teams, then there are going to be 7 boys and 2 girls on each team. Again, Michelle needs to have the same number of boys and the same number of girls on each team, and she wants to have the most number of teams possible. So she needs to determine the greatest number of teams that she can have. We know that that is 6. She can then divide the number of boys by the number of teams to determine the boys on the team, and she can also divide the number of girls by the number of teams in order to determine how many girls are going to be on one team. Let's turn to the top of page 72. It says, you helped determine the greatest number of fruit baskets that can be created and the greatest number of teams that can be organized. A common factor is a factor of 2 or more numbers. The greatest common factor, or GCF, is the greatest factor 2 or more numbers have in common. To get started on page 72, take a look at number 3. I'd like you to do letters A, B, and C with your group members. It says to determine the greatest common factor using prime factorization. If we take a look at letter A, when it asks us to write the prime factorization of a number as a math statement, what we want to do is make sure that we write it out in expanded form. So if we take a look at 24, the prime factorization is 2 times 2 times 2 times 3, and the prime factorization for 36 is 2 times 2 times 3 times 3. We are not using exponents when we write out the prime factorization. When we write out our prime factorization in expanded form, it will help us answer letter B. We will be able to find out what factors are common to both of the numbers. So in this case, the common factors of 24 and 36 are 2 times 2 times 3, or 2 squared times 3. So what you want to do is take a look at the prime factorizations that you write out for each of the numbers and try to match up pairs when you write them out in expanded form. So you can see that here is one of the 2's that they have in common, another 2 they have in common, and a 3 that they have in common. So you have to look at both lists and compare them in order to try and help you determine what the GCF is going to be. If we look at letter C then, 2 squared times 3 is going to give us 12. That is what the GCF of 24 and 36 will be. Let's take a look at number 4 then with your group members. After answering A, B, and C for number 3, let's see if we can write a rule for determining the GCF of a set of numbers once you have completed the prime factorization for each number. So go ahead and do that with your group members. So in order for us to determine the GCF, what you have to do is look for factors that are common to both in this case, or however many numbers that you are comparing when trying to find the GCF. Let's take a look at number 7 at the top of page 73. With your group members, determine the GCF of each pair. I would like you to do letters A through D. If we take a look first at letter A, I am going to write out the prime factorization in expanded form so it's easy for us to kind of match up our pairs like we talked about on the last page. So if we look at 20 and 40, we have one match here, we have one match here, and then we have one match here with our 5's. So 2 squared times 5 is going to give me 20. So 20 is the GCF of 20 and 40. If we take a look at letter B, the prime factorization for 12 is 2 times 2 times 3. Prime factorization for 30 is 2 times 3 times 5. So I have one pair here, one pair here. 2 times 3 is going to give me 6. So that is the GCF of 12 and 30. For letter C, the prime factorization of 36 is 2 times 2 times 3 times 3. And for 48, I have 2 times 2 times 2 times 2 times 3. So I have a pair here of 2's, I have a pair here of 2's, and I have one pair of 3's. So 2 squared times 3 is going to give me 12, and that is going to be the GCF for 36 and 48. And finally, if I take a look at letter D, the prime factorization for 37 is 1 times 37. And for 81, 3 times 3 times 3 times 3. You can see that there are no factors that these two numbers have in common other than the number 1. So 1 is going to be the GCF for 37 and 81. If we take a look at number 8 down at the bottom of page 72, like our example in letter D that we just answered, if the GCF of two numbers is 1, then we know that the numbers do not share any other common factors. Let's take a look at the top of page 74. Two numbers that do not have any common factors other than 1 are called relatively prime numbers. Take a look at number 9 with your group members. Go ahead and name two other pairs of numbers that are relatively prime. At least one of the numbers must be a composite number, and explain how you know that they are relatively prime. Two examples that the book came up with for number 9 are 12 and 31 and 8 and 9. Both of those pairs of numbers are relatively prime because neither pair of numbers shares a common factor other than 1. So that is the explanation that you should have no matter what pair of relatively prime numbers that you came up with. I'd like you to copy down this T-chart. I just created it on page 75 because there was some extra space. But I think that this is going to be helpful in determining either the LCM or the GCF when we are trying to figure either of those out using prime factorization. So I just wrote down each of the steps that you were supposed to follow in order to determine the LCM or GCF using prime factorization. So hopefully this is helpful. If we take a look first at the left side in determining the LCM, the very first thing that we want to do is we want to determine the prime factorization, and we want to make sure that we are using exponents. And remember that you can use factor trees to help you determine the prime factorization if needed. The second thing then that we want to do is determine which power is greater, and the third and final thing then is that we are going to multiply in order to figure out what the LCM is. So if we look at the example that I have down here at the bottom, the prime factorization of 4 is going to be 2 squared. The prime factorization of 6 is going to be 2 times 3, and the prime factorization for 10 is going to be 2 times 5. If I look at each of the prime factorizations, again, I want to determine which power is greater. So I'm going to take 2 squared times 3 times 5. And when I multiply those together, I am going to get 60 for my LCM. If I look at the other side of the T-chart and try to determine the GCF using prime factorization, the very first thing that I'm going to do is I'm going to use a math statement, or I'm going to write out my prime factorization in expanded form. Then I'm going to compare the factors that each number has in common. Remember, I talked about either matching up the pairs if you have 2 numbers that you're comparing, or you can match up sets if you have 3 numbers that you're comparing. And then the last thing that you want to do as well, just like for the LCM, is multiply for the GCF. So if you look at our example, number 24, 40, and 72, if I'm trying to find the GCF of these 3 numbers, the prime factorization for 24 is going to be 2 times 2 times 2 times 3. For 40, it is going to be 2 times 2 times 2 times 5. And for 72, it is going to be 2 times 2 times 2 times 3 times 3. Now I have to make sure that I match up. In this case, it's going to be a set factors that each of the 3 numbers have in common. I can see here that we have the common factor of 2, and it is matched up 3 times. So 2 cubed is going to give me 8. So the GCF of 24, 40, and 72 is going to be 8. That is going to do it for Lesson 2.3 on investigating factors and greatest common factors. Please let me know if you have any questions. Thanks.